Hello calculus fans, and welcome to section 3.2 where we talk about the product and the quotient rules. You'll notice there's no handout for this section, so hopefully you remember how to take notes the old-fashioned way by writing on a piece of paper. The reason is there's not really much to this. What I used to do when I first started teaching is I would put a couple of proofs, and the book has a geometric proof. I used more of an algebraic proof because I think it was just an easier proof to write and to understand. And I'd have a question on the test in chapter 3 about one of the proofs. But it seems lately we seem to be going away from proofs and more into applied problems. So I haven't been doing that lately. So because of that, section 3.2, there's just a couple of rules to state, and then we'll practice a lot of problems. So there's not really much to put on a handout. So if you remember earlier we talked about the sum rule and the difference rule. So if we have something like y equals 3x squared plus e to the x, and if we want to take the derivative, we want to find y prime, I don't have to somehow combine these first and then take a derivative. The sum rule says, well, the derivative of this sum is just the sum of the derivatives. So I can basically just take the derivative of each of these. So I could use a power rule on the first one, get 6x, and then the derivative of e to the x is just e to the x. And we had something very similar for the difference rule. So if we had something like y equals 5x to the minus 3 minus 8x, we could just take the derivative of each of these individually. So we could just use the power rule again and get negative 15x to the negative 4 minus 8. So it would be really nice if we had a product and quotient rule that let us do something just like that. But will it work? Let's check it out. So just to experiment, let's think if we wanted to take the derivative of, I'm going to go to a really easy one that we already know the answer to, of x times x. Well, it would be really nice if to take the derivative of one thing times another thing, we could just take these individual derivatives. Let's see if it would work. So if I take the derivative of x, I get 1. Take the derivative of the other x, I get another 1. So the derivative would just be 1. But you might think, I'm not sure about that, because isn't x times x just x squared? And we already know the derivative of this. We can use the power rule and get 2x. So what that shows is there is no easy product rule like this. The sum rule and difference rule, they work really nicely. This one just doesn't work. So we're not going to be able to do that. But there is a product rule and also a quotient rule that we can use that will always allow us to take the derivative of products and quotients. So the product rule looks like this. Let's say you want to take the derivative of f of x times g of x, and these are just two differentiable functions. So I'm going to show you two ways you can write this. I'm going to say it the way it's traditionally taught. So it's traditionally taught like this. This is equal to the first term times the derivative of the second term plus the second term times the derivative of the first term. So it's usually taught that way. But I'm going to show you another way also that's equivalent. The other way that I think is a little easier is if you just write this down twice and you add them. So you would say something like this. I would say this is equal to, I'm just going to write that down twice, f of x times g of x plus f of x times g of x. Then I'm going to take terms with the derivative. So first I'm going to take f prime, then I'm going to take g prime. And if you look at these two answers, more the traditional way here and this new way here, algebraically they are the same, right? Because multiplication and addition are both commutative, so I can switch them around. So we have f of x times g prime of x, which is right here. And then we're adding g of x times f prime of x, which is right here, right? Because when you multiply, order doesn't matter. Okay, so just to practice, we're going to take the derivative of a product, f of x times g of x. The way it's traditionally taught is this. First term times the derivative of the second term plus the second term times the derivative of the first term. So that's one way to do it. I think it's most commonly taught that way, but also the other way that's equivalent, and I think it's a little easier to remember, is just to write this down twice with and add with an addition between the two, and then take turns with the derivative. So f gets the derivative here, g gets the derivative here. Either way works just fine. Now I know what you're thinking. You just saw a formula and you just cannot wait to use it. So let's not waste any time. Here's one we can try. What about this example? G of x equals the square root of x times e to the x. Okay, just wait for me. Try it out and then, press pause, try it out, and then check back in. All right, so I guess what I'll do, maybe I'll just do it this way. I'm gonna write it down this way. Again, both of these work. I'm just gonna write it down this way. So I'm gonna say g prime of x equals, and I'm going to just write this down. I'm going to write the problem down twice. I'm going to add. But then what I'm going to do is take turns with the derivative. So first I'll take the derivative of that one, then I'll take the derivative of that one. So then when I take the derivative of this one, remember square root of x, that's really x to the 1/2, right? So this square root of x is really x to the 1/2, so we can use the power rule here. So g prime of x equals, so this is going to be 1/2 x to the 1/2 minus 1, which is negative 1/2. So we'll get 1/2 x to the negative 1/2 times e to the x plus the square root of x times e to the x, right? Because the derivative of e to the x is e to the x, so that just stays e to the x. Now this one, you can leave this like this if you'd like, but I'll show you what you'll typically see in the back of the book. So when you have this x to the, well, let me just write that term. So when you see this answer, which is fine, you can leave it like that, but in the back of the book, you'll usually see that they're going to rewrite this. They're going to write this as 1 over x to the positive 1/2. So this right here, they are going to think of this. They're going to use that rule from algebra. X to the negative n equals 1 over x to the positive n. So they'll use that rule to rewrite it as 1 over x to the positive 1/2. Then they're just going to multiply this. So you'll see 1 over 2, but they're not going to write x to the 1/2. They're going to write the square root of x. So when you look in the back of the book at some of these, don't be surprised if you see this instead of what you've got. And your answer is fine, by the way, so it doesn't matter. And then sometimes our author just loves factoring, so they may even factor out e to the x. They may even do something with the square root of x, but you don't have to. You can leave it just like this. Just in case, so let's do one more little factoring here. You don't have to do this, but could you see how if you really love factoring, you just love it, you're going to do it every opportunity you can, we could factor e to the x out, right? And we would just get 1 over 2 times the square root of x plus the square root of x. So you don't have to. Remember, this answer is just fine right here. Right here is good. If you want to rewrite it, that's good too. And if you love factoring, that is also good. All right, so that was the product rule. Next up is the quotient rule. Now this one's not quite as easy to remember. And the quotient rule, honestly, is a bit of work. So when you can avoid it, sometimes it's better to avoid it. But let's take a look at what it says. So this is one where we're going to have something like f of x divided by g of x. And we want to take the derivative of this whole thing. So you could put d dx here, or of course if you wanted to, instead of this, you could put a little prime symbol here. So the way this one goes is this. Okay, I'm going to show you a couple ways. So I'll show you, typically you'd say something like this. So the derivative of a quotient like this, it's going to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the square of the denominator. Okay, that one's not as easy to remember. One thing you notice is that just think the quotient rule, it's going to be worst case scenario. So instead of adding, we subtract, which means now order matters. I can't flip-flop these or I'll get the wrong answer. Right, so quotient rule, it's subtract. Remember the product rule, we added, right? We had an add here, but now we subtract. So it's denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the square of the denominator. And there is a little jingle to make this a little easier to remember. And some people like it, so it is kind of easy. So the jingle has to do with this being the high and this being the low. Numerator would be the high part of the fraction, denominator low part of the fraction. And the jingle goes like this. Low d high, meaning derivative of high. Low d high minus high d low, all over the square of the bottom we go. Pretty snappy, huh? And let's try it again. So we're going to start with low. Remember, it has to start with low. So when you're trying to take the derivative of this, you go low d high minus high d low, all over the square of the bottom we go. So that's it. That is the quotient rule. And both of these can be proven with a geometric proof or, like I said, an algebraic proof, but we're not going to do the proofs in here. So we just have to know them. We have to know these. So the best way to get to know these is to just try this. Okay, if we were in a class right now, in a face-to-face class, I would have you do something like this. I'd move this off, and I would do this, and I would say, this time I'm not going to put the f of x, I'm just going to write f in g prime, right? And also f divided by g prime. And I would say, okay, see if you can, without looking, try to pull these out of your memory as much as you can. I'd say, if we were in class, I would just say, okay, just take a minute, scrap piece of paper, and see if you can come up with these. So you should try it. This is a really good way to try to memorize things, is just try to write them down, everything you can remember, even if you can't get it quite right, and then immediately look at the answer, okay? So just try them out, see if you can write these down. And hopefully you'll press pause and then try to write them down. Okay, so hopefully you tried. Maybe you had success, maybe not. At first, it's going to take a little practice. So for the product one, this one is a little bit easier typically. So remember what you can do. You can just write that down twice. F times g plus f times g. Take turns with the derivatives, f prime and then g prime, right? Or remember, the traditional way would be this: first term times the derivative of the second term plus the second term times the derivative of the first term. They both work just fine. Okay, now this other one, for the quotient rule, it's not quite as easy to remember. But maybe you can remember the little jingle. If you want to remember the jingle, remember it starts low. We go low d high minus high d low, all over the square of the bottom we go. And there you have it, the product rule and the quotient rule. So let's try one with the quotient rule. But before I even start, there's a reminder we need to know about using the quotient rule. So when you do use the quotient rule, I'm writing it in red so we always remember. Quotient rule, we always clean up the numerator. So the numerator, a lot of times when you're using the quotient rule, will get really messy. but oftentimes it will simplify quite a bit. So when you use the quotient rule, after you get through this step here, make sure you go and look for like terms and see if you can clean it up anyway. Okay. So with that in mind, let's take a look at our first problem here, which will be, say, y equals e to the x over 1 plus x. And we want to find the derivative, of course. We can see that we've got a quotient here, so we're going to have to use the quotient rule. So if y prime equals, remember how it goes, low, right? Low meaning the denominator, low, d high, so we multiply by that derivative. Is that right like that? Is that okay? Of course not. We can't do that. We have to put it like this, right? Low is two terms, low, d high, minus, it's always a minus, right? Minus high, d low, all over the square of the bottom we go. Okay, so we've got it set up. Now we just have to do the work. So I have to take the derivative of this and take the derivative of this. Both of these are pretty easy, right? The derivative of e to the x is just e to the x. So this would give us 1 plus x times e to the x minus e to the x times 1, right? The derivative of 1 is 0, the derivative of x is 1, so the derivative of 1 plus x is just 1. So e to the x times 1 is just e to the x. And on the bottom, we've got 1 plus x squared. Okay, now in light of this up here, we're probably going to want to distribute this through and see if we can clean this numerator up. Denominator, you hardly ever want to do anything with it because all that can happen here, I could square this, I could expand it, but really that won't do much for us. So this says always clean up the numerator. The denominator, you typically just want to leave alone. Just leave it as whatever this is squared. But this other one, we can distribute this e to the x through. And when we do that, we'll get y prime equals e to the x plus x e to the x minus e to the x all over 1 plus x squared. And see, now we've got e to the x minus e to the x, so those will cancel. And this happens a lot with a quotient rule. That's why I always want to clean up the numerator. So we end up with x e to the x over 1 plus x squared. Okay, we've got another example here. Y equals 5x cubed plus 3 times the square root of x all over x. So do you remember when I was talking about the quotient rule? I said typically want to avoid it if you can. It's a lot of work. Can you see now this one, it is a quotient. We could use a quotient rule here, but there's a much easier way to go. Can you think of what we could do? Okay, I think you can. I think some of you are figuring it out. Well, we could split this up, right? Because we know that like if you have something like 5 plus x over 8, for instance, that's the same as 5 over 8 plus x over 8, right? And so we could go backward too. If we started here, we could go here. But what that means is we can split this up. So we can split this up as 5x cubed over x plus 3 times the square root of, or times 3 times the square root of x over x. And now we can see this will simplify. These x's cancel. And this, remember that is really just, this is really just 3x to the 1/2, right? So we can use this rule that we learned a long time ago in the good old days of algebra. X to the m minus n. So this first term, the x's will cancel. So that just goes away and this becomes x squared. So really we get 5x squared. And then over here, we're going to have plus 3x to the negative 1/2, right? Because this will be 1/2 minus x to the 1, right? Because x is just x to the 1. So we'll have 3x to the 1/2 minus 1. Okay, so then we can take the derivative. I'm going to do something right here, and hopefully you'll have a hard time even looking at it, okay? But I'm just going to do it anyway. 10x minus 3 halves x to the minus 1 half minus 1 makes minus 3 halves. Okay, is that looking good or not looking so good? Hopefully you're saying it looks terrible, because can I just put equal signs wherever I want? No. This is why. This is definitely not why. These are not equal to each other, right? So I have to remember y prime, right? Someday when you're done with college, you will be making the big bucks out there because you will be the kind of person who notices details. So when we go from y to y prime, we have to mention that this is y prime. This is the derivative right here. Okay, I think you look like you're ready to try another one. So let's try this one. G of x equals x squared minus 2 over 2x plus 1. Now this one, because there's two terms down here, this one's not going to be quite as easy to break up. So this one we're probably just going to be stuck using the quotient rule, which is okay. The quotient rule is great. It allows us to do these things. Okay, so it's just when you can avoid it, sometimes it's easier to avoid it. But in this case, it looks like there's no avoiding it. So we just have to use the quotient rule. So this is g of x, and we, of course, want to find g prime of x. So I'm going to write this down. Now what you should do is take that mouse, or if you have a laptop, press the button for pause and try it yourself, okay? So press pause, try it yourself. Okay, so hopefully you tried it yourself and you said, okay, I've got the little chant with me, low d high minus high d low, all over the square of the bottom we go. So let's try it. So we have low d high, so derivative of high, right? Low d high minus high d low, derivative of low, all over the square of the bottom we go. Okay, so it's set up. Now we just have to try it out. So I have to take the derivative of this and this. And so that would give us, let's see, 2x plus 1 times 2x minus x squared minus 2 times 2 all over 2x plus 1 squared. Now sometimes at this point students say, hey, wait a minute, there's a temptation to cancel here, but remember we can't cancel there unless there's also 1 over here, right? If there were a 2x plus 1 over here, then we could cancel. But otherwise we're doing some crazy thing like this. Like if we have, let's say 5 minus 10 over 5, right? Now really what this is negative 5 over 5. This is equal to negative 1. I can't just go, hey, I'm going to cancel those and say, oh, I guess it's negative 10, right? It doesn't work that way. So same thing over here. Factors cancel, but terms don't. So I'd have to have a factor in all of these. So in other words, we can't do that. But remember, we always want to clean up the numerator. Every time you do the quotient rule, you should think, I should clean up that numerator. And so that means we should distribute this through here, distribute this through here, and see what we get. But be really careful. There's a negative here, right? So this negative has to, at the end, get distributed through this whole thing here. So let's see what that gets us. Okay, that will give us, okay, so I would get 4x squared plus 2x. Okay, I'm going to be careful here. I'm going to get minus 2x squared and then plus 4 all over 2x plus 1 squared. Okay, so just to verify, we get 4x squared plus 2x. Then over here, so if I ignore the negative, I'm going to get 2x squared, but then that negative comes through to make it negative 2x squared. Here I get minus 4, but then the negative comes through to make it plus 4. And then we can clean this up a little bit. We got like terms with the x squareds, right? 4x squared minus 2x squared is 2x squared plus 2x plus 4 all over 2x plus 1 squared. And again, notice that the denominator, I didn't expand it. When you do the quotient rule, almost always, you're just going to want to leave that denominator alone. Yeah, just generally just leave it alone. Now what you could do here, you can see you could factor out a 2 if you wanted to, but you really don't have to. That won't really do much for us. You could factor 2 out if you want to, but from there you wouldn't be able to do anything. So it's good just like this. Okay, I've got one here I wanted to show you. This is one from right out of the book. This is from number 18 and the 9th edition of Stewart. And it looks like this. It looks like a good one for the product rule. And the product rule would work, but it would be a ton of work. So we'd have like first term times the derivative of the second plus second term times the derivative of the first, or the other version of the product rule. Either way, it's a lot of work, but can you think of something that might just be faster where we wouldn't even need the product rule? So if you look at this one, it's like a 2-term expression times another 2-term expression. Doesn't that seem perfect for the FOIL method? First times first, outside times outside, inside times inside, last times last. Because if we did that first, this would probably be much easier. So let's take a look at it. So first times first, w squared times w to the negative 1. Okay. I'm going to tell you 2 of them that get mixed up a lot from algebra class. Okay. Here, this is saying take m of these a's, line them up, multiply them together, then multiply by n more of them lined up, multiplied together. So the answer here is going to be a to the m plus n. That's where we add, right? But in this other case, we have to multiply, right? So m times n. So with that in mind, right here we're going to get w to the 2, w squared times w to the negative 1. 2 plus negative 1 is just 1, so I have just w. Then the outside, I'm going to get minus w to the minus 2. Inside, we get plus 3w to the 0. And then last times last, we get minus 3w to the negative 3. But w to the 0 is just 1, right? That's just 1. So really we've got w minus w to the minus 2 plus 3 minus 3w to the minus 3. So to find h prime of w, we just need the power rule. So remember, w is our independent variable, so this is going to be 1. And then the power rule, this negative 2 will come down and multiply by the negative. So you get minus 2 times minus 1, basically, which gives us plus 2 w to the minus 3. Because remember, it drops by 1. Now 3 is just a constant, so the derivative of 3 is just 0, so that just goes away. Then we have the power rule, minus 3 times minus 3 is plus 9, w to the minus 4. And that is almost certainly going to be easier than using the product rule on this. So when you have one like this, sometimes it's easier to multiply first and avoid the product rule. Let me mention one more thing that could come up sometimes. So if I have y equals 5e to the x, or y equals 5x e to the x, one of these requires the product rule and one doesn't. So the product rule is when we have a function or a variable times some other function or variable. So see, this is like a 5x times e to the x. Where here, this is just 5, just the number 5. This is just a constant. This just goes along for the ride as you take the derivative. So you could use the power rule here, the product rule. So let me show you that you could use it. I wouldn't, because it's kind of a waste of time, but you could say, okay, I'm going to write this down twice, and I'm going to take terms with the derivatives. And you can see why you're wasting your time when you do it this way. The derivative of 5 is just 0, so it just goes away. So you end up with 0 times e to the x, which is just 0. You get 5 e to the x, because the derivative of e to the x is e to the x. So with one like this, the 5 just goes along for the ride, and the derivative of e to the x is e to the x. So over here it's completely different. So here we need the product rule. Here y prime is going to be, if I write it out like we did, we have this written down twice. Take terms of the derivatives. And here we'll get 5 e to the x plus 5x times e to the x. So what the point I'm making is, if you have a constant times a variable or a constant times a function, you don't need the product rule for that constant. You can use it, but you're just sort of wasting your time, because you're going to get a derivative of 0 when the constant comes up for its derivative. So if it's just a constant in front of the variable or the function, it just goes along for the ride. So it just goes along for the ride. The derivative, if y equals 5 e to the x, y prime is just 5 e to the x. We take the derivative of that, and the 5 goes along for the ride. Over here, it's completely different. We need the product rule here. All right, so it was kind of a short section. There's just 2 rules, and now you just have to use them a lot so that you can get used to them. So you know what that means. Just take a look at section 3.2, try the homework. There's just a bunch of practice problems, sort of like we did. And you have to know the product rule and the quotient rule. The product rule usually doesn't give us too much trouble. The quotient rule sometimes does, so make sure you practice. Check your answers in the back of the book, or if you're on, the digital version, check your answers there. The odd answers are always given. And then if you still have questions, just let me know.